Welcome back to the deep dive. Today, we're looking at something pretty cutting edge in the real-time data world. We're focusing on Laravel Nightwatch, their observability platform, and tackling how they cracked a huge problem, scaling from basically 0 users instantly to handling billions of events while keeping insights, well, practically instantaneous, sub-second fast.
That's the core challenge, isn't it? When you're launching something for a community as massive and global as Laravel's, you don't just scale up, you explode outwards. Our sources really dig into how Nightwatch built this system, aiming for over 1 billion events per day. They use this really interesting mix of AWS managed services and the sheer analytical horsepower of ClickHouse Cloud.
It's that scale, yeah, but the real achievement we're digging into today is holding onto that sub-second query latency. Like you said, anyone can store 1 billion events, but asking a conference question about them and getting an answer back faster than you can blink, that's the hard part.
Absolutely. And you need the context of the framework itself to really grasp the challenge. Laravel runs millions of apps worldwide, so even if only a small fraction of those developers flip the switch on Nightwatch on day one, the data volume is just immense. And here's the multiplier. A single web request hitting an app doesn't create one data point. No, it can spit out hundreds of little observability events. Think database queries, cache hits, misses, exceptions thrown, notifications sent.
Hundreds per request. Wow, that data velocity potential is just, explosive.
It really is.
Okay, so planning for that kind of instant, global, exponential growth, it forces your hand, right? You can't use standard off-the-shelf solutions easily. What were the absolute must-haves, the non-negotiables that shaped the whole architecture from the start?
Yeah, they had to be really strict.
Yeah.
4 main things based on what we've seen. First, ingestion. It had to reliably swallow millions of JSON events every single second. No dropping data.
Millions per second.
Okay. Second, those dashboards developers would be staring at. They needed sub-second analytical queries. Real-time means real-time.
Right. Third, scale. True horizontal scaling. To just absorb these wild, unpredictable traffic spikes. No manual fiddling when load hits. And the fourth, that always seems to be the tricky one. The fourth was maybe the toughest balancing act. Deliver all this power cost-effectively with low maintenance. Had to feel simple, like Laravel users expect, even if the backend was complex.
That tension you mentioned, building this, it's basically a custom huge data warehouse, right? A massive system. But you need to package it so activating it feels like flipping a switch. That definitely demands a specialized design.
Exactly, and that led them pretty directly to the core decision. Separate the workloads, build a decoupled streaming-first architecture. It's really foundational for scaling like this today.
Okay, walk us through that separation. They didn't just throw everything into one big database, did they? No way. No single database could handle both the transactional side and this kind of massive real-time analysis efficiently. Not at this scale. So they split it cleanly. User accounts, billing info, org settings, the typical transactional stuff that went into Amazon RDS for PostgreSQL. Standard choice, very reliable.
Makes sense.
But the fire hose of data, the telemetry events, metrics, traces, query logs, all the high-volume analytical stuff, that got piped straight into ClickHouse Cloud.
All right, let's follow the data's path. This is where those AWS managed services really come into play. Where does the data actually enter the Nightwatch system from the user's app?
Okay, so the first stop is Amazon API Gateway. That's the front door. It's built to handle just huge numbers of connections coming in from all those agents all over the world.
Got it. API Gateway takes the initial hit, then what?
From there, it goes right into an AWS Lambda function.
Lambda. So that's like the bouncer and the prep cook.
Yeah, pretty much. Lambda does stateless validation and enrichment, checks the format, stamps it, adds metadata like org IDs. Basically cleans it up and makes sure it's legit. Once it passes muster, Lambda publishes the cleaned up event into the main streaming backbone. Amazon MSK, that's their managed Kafka.
And it's partitioned in MSK, right, for handling that sheer speed.
Exactly, partitioned for parallelism and throughput.
So MSK, the Kafka layer, that's the durable buffer. The engine room, like you said, it holds the data reliably. But getting data out of Kafka and into an analytics database, that's usually where you hit a wall of complexity, right? Building custom ETL pipelines, managing consumers. Sounds like an operational headache. How'd they dodge that?
This is a really key point, and where choosing ClickHouse Cloud paid off strategically, they used a feature called ClickPipes.
ClickPipes?
Yeah. Instead of the Nightwatch team having to build, run, and scale their own Kafka consumer fleet, using Kafka Connect or custom code ClickPipes, just subscribes directly to the MSK topics.
Oh, wow.
It's a huge deal for that low maintenance requirement. It cuts out a whole layer of potential failure points, reduces latency, and basically shifts the responsibility for ingestion into the managed ClickHouse service itself.
Okay, that is a game changer for operations.
Mm-hmm.
So the raw JSON lands in ClickHouse via ClickPipes. But raw JSON isn't fast to query across billions of rows, is it? How do they get that sub-second speed inside ClickHouse?
Right, you need optimization within the database, and the answer there is materialized views. This is kind of the secret sauce for speed in systems like this.
Materialized views, how do they work here?
So the raw, messy JSON might land in a base table, but then you define materialized views that automatically transform and aggregate that data as it arrives. Think of them like automated summary tables. They pre-calculate aggregates, maybe parse the JSON into cleaner columns, all optimized for reading quickly later.
So when my dashboard asks for, say, the average database query time in the last hour,
Exactly. ClickHouse isn't desperately scanning billions of raw JSON blobs. It's hitting a much smaller, pre-aggregated, materialized view that basically already has the answer computed much, much faster.
that efficiency powers the whole user experience then.
Huh.
Let's quickly trace the stack that delivers those insights back to the developer's browser.
Sure. The front-end dashboards themselves run on AWS Fargate, managing Amazon ECS containers.
Fargate, so serverless containers.
Precisely. Again, hitting that low maintenance goal. The Nightwatch team isn't managing EC2 instances, patching OCs, or figuring out cluster scaling for the front end. Fargate handles that.
Okay.
Then you've got Amazon Elasticache using Redis to speed up things like session lookups and caching common query results. Standard practice for performance. And finally, Cloudflare's CDN sits in front of everything, making sure those dashboard assets load quickly for users anywhere in the world.
Okay, hang on. Let me count. API Gateway, Lambda, MSK, RDS, ECS, Fargate, Elasticache, plus ClickHouse Cloud.
Yeah.
That's like 8 different major services working together. Even if they're managed, doesn't just wiring all that up and configuring become its own massive complexity?
Yeah.
How does that square with low maintenance?
That's a really fair question. And yes, the complexity absolutely shifts. It moves away from building and patching custom software like running your own Kafka cluster or writing ETL scripts from scratch. Instead, the complexity is in the configuration and integration of these powerful managed services. But the trade-off is generally worth it for a small team.
How so?
Because AWS and ClickHouse are handling the really hard parts, the underlying resilience, the patching, most of the scaling mechanics. The team configures the connections, defines the schemas, sets the rules, but they're not managing servers day to day in the same way. They traded the illusion of simplicity from a single system for the specialized power, and ultimately the managed resilience, of using the right tool for each job.
Right, leveraging specialists instead of a generalist. Okay, let's zoom in on the 2 biggest specialists here. Amazon MSK Express and ClickHouse Cloud. Why were they so crucial? Start with MSK Express.
Okay, MSK. They needed that streaming buffer, as we said, and one that could handle insane bursts. Their load tests showed MSK Express handling over 1 million events per second. The key reason for choosing the Express flavor specifically was agility and elasticity.
The performance numbers in the source material were pretty eye-opening there.
Yeah, they highlighted that MSK Express can scale up something like 20 times faster and recover from issues 90% quicker than standard Kafka brokers. And crucially for the team, there is no need to pre-provision or even think about storage sizing. MSK Express just handles that elastic scaling automatically. That simplified resilience was vital for facing that unpredictable launch day traffic.
Okay, that covers the streaming backbone. Now, the destination. ClickHouse Cloud. We know it's fast. But why? Why can it chew through billions of rows in under a second when a traditional database would just choke?
It really comes down to the fundamental architecture, columnar storage.
Columnar. Explain that quickly for us.
Sure. So traditional databases store data row by row. If you query 3 columns out of 50, they still have to read all 50 columns for every relevant row off the disk. ClickHouse stores data column by column. So if your query only needs those 3 columns, ClickHouse only reads the data for those 3 columns. It ignores the other 47 entirely.
So vastly less data read from disk for typical analytical queries.
Exactly. That's why you see performance gains of up to like 100 times faster compared to row-based systems for these kinds of analytical workloads.
And this columnar approach, it helps with cost too, right? Not just speed.
Absolutely. Because data within a single column is often similar or repetitive, ClickHouse can use highly specialized compression algorithms. We're talking up to 90% storage savings compared to uncompressed data. When you're ingesting billions of events daily and need to retain them, cutting your storage footprint by 90% is, well, it's fundamental to making the whole thing economically viable.
No kidding. Okay, building anything global like this always throws up hurdles beyond just raw speed. Let's touch on two big ones mentioned. Managing multi-region complexity. How do they tackle that?
Yeah, that's never trivial. You need low latency globally, plus you have data sovereignty rules to worry about. Instead of complex custom networking, they leaned heavily on AWS features, things like VPC peering to securely connect their different regional networks together as if they were one. Plus, RDS read replicas in different regions and global load balancing to direct users to the nearest endpoint and ensure redundancy. It aims to make a global setup feel local to the user and the services.
Okay, managed services smoothing over the network complexity. What about the other big one? Keeping those queries sub-second fast, even as the data volume explodes into the trillions of rows over time.
That took some specific tuning inside ClickHouse itself, beyond those materialized views we talked about.
Oh.
They used smart time series partitioning, basically structuring the data physically based on time intervals. So if you query the last hour, ClickHouse knows exactly which partitions contain that data and can completely ignore the rest, potentially skipping months or years of irrelevant data instantly.
Makes sense. Any other tricks?
Yeah, they also deployed specialized ClickHouse codecs. You can think of these like superpowered compression and encoding schemes applied per column. They're designed not just to save space, but also to allow ClickHouse to skip reading chunks of data within a column if the query doesn't need them. It's another layer of making queries touch the absolute minimum amount of data necessary.
So it sounds like a lot of the complexity went into configuring these systems to be hyper-efficient.
It did. And one more thing, separating compute workloads. They made sure that the processes doing the data ingestion and running those background materialized view updates could scale independently from the resources handling the user-facing dashboard queries.
So a huge influx of data doesn't slow down dashboards, and a sudden rush of users looking at dashboards doesn't bottleneck ingestion.
Precisely. It prevents resource contention between those different types of work.
Okay, so after all that intense engineering, the launch, did it work? What were the results on day one?
The launch numbers were pretty impressive, yeah. A clear validation. In just the first 24 hours, they got 5,300 user signups.
Wow. Okay. And data volume?
They processed 500 million events on that first day. 500 million.
500 million.
Yeah.
And the crucial metric, the latency.
Average dashboard request latency, 97 milliseconds.
97 milliseconds. That's incredible. That's processing 500 million events in the background, analyzing things like, what was it? It's 760,000 exceptions logged in real time.
Exactly. All while serving dashboards in under 1/10 of a second on average. It showed they scaled from zero to massive volume without breaking a sweat, performance-wise.
And the system's design ceiling.
The architecture is built to handle over 1 trillion monthly events without performance issues. So, plenty of headroom for future growth. The foundation is solid.
So with that foundation proven, what's next? Where does Nightwatch go from here?
Seems like it's mainly about expansion and formalizing things. First, more regions. Expanding globally to meet customer demands for data residency, especially outside the current US and EU footprints.
Data sovereignty, yeah, that's huge now.
Definitely. Second, compliance. They're going for SOC2 certification, which is often critical for enterprise customers or those with stricter security needs.
Makes sense. And feature-wise?
Just broadening the data collection capabilities and adding more advanced monitoring features, layering more value on top of that massive data engine they've built.
Okay, so let's distill this. The big takeaway from this deep dive, for me at least, is that Nightwatch's success offers a really clear blueprint for anyone else facing this kind of insane real-time data scale challenge.
I think that's right. And the blueprint really hinges on that strategic trade-off we discussed. You sacrifice the apparent simplicity of a single do-it-all database. Instead, you embrace specialized tools. A high-performance analytical database, usually columnar like ClickHouse, paired with a robust managed streaming service like MSK Express in this case. That combination is what unlocks the performance and the cost-effectiveness needed at global scale.
And it's a powerful model. Which brings us to our final thought for you, the listener. Think about this decoupled streaming and analytics pipeline, specifically that combo. High-volume elastic ingestion feeding into a system capable of massive compression and sub-second queries. How could you apply that pattern outside of web application monitoring? Where else do you see massive high-velocity data streams that need near real-time analysis?
Yeah, think about maybe high-frequency financial trading data. analyzing market movements in real time? Or what about processing sensor data from a huge global network of IoT devices, monitoring industrial equipment, environmental sensors?
The potential applications are vast.
The architecture's proven, it's ready for the data, whatever the source. Honestly, the barrier to building these kinds of extreme scale systems is lower than it's ever been, thanks to these managed services.
Food for thought. We'll leave it there for this deep dive. Catch you next time.